Hi, so today we've got another interesting bit of lab equipment, one of my favourite sorts, stupidly expensive but now completely obsolete. This is a DNA sequencer made by 454 Life Sciences, who were subsequently bought out by Roche. The product was introduced I think around 2007. A few dates that I found on this suggest that this one was made around 2011-2012 sort of time. This came through computer recycling companies. This is one of the things that's been bought from the Patreon and YouTube money. This was, I think, including shipping, this was about £210. And doing a bit of research online, the original price of this thing was $500,000. And not only that, basically this sequence produces DNA sequences, and it runs for, I think, between 12 and 24 hours to produce a sort of several million sort of DNA bases or whatever. I'm not that familiar with the terminology, so excuse my ignorance of all this biotech sort of squishy science stuff. But the cost of the reagents to do one run is $6,000. So if you think inkjet ink is expensive, just try running a DNA sequencer. This is what's known as a sort of second or next generation DNA sequencer, and these have now been pretty much made obsolete by third generation models, which produce sort of much larger outputs at a much lower cost. So purely on the basis of the running costs, this thing is pretty much completely obsolete. I believe it was discontinued this year, 2016. I don't know whether they still supply the chemicals for it, but obviously as soon as those die out, then the thing is basically a paperweight. But so if it's costing $6,000 a go, it's quite probable that there are newer models that are much cheaper, so it's just not worth keeping and running. Now, this is one of these cases where I saw it on eBay and slightly underestimated the size and weight of the thing. I looked up online, I did find a figure online for the weight, which I think might have actually been for the smaller model. I knew this was going to be fairly heavy because it's got this great big UPS in the bottom of it. Of course, if you're running a sort of 10-hour or whatever run and you get a power cut in the middle of it, that's $6,000 worth of chemicals down the toilets. This isn't all mounted. Basically what happened was, because I'd underestimated the size and the weight, this basically got offloaded onto the pavement outside the house on a pallet. And because although it does actually have wheels on it, there's a couple of sort of stepped up path and so on, so I actually had to sit outside in the dark for about an hour just stripping stuff off of this to get this light enough to get it up the ramps that I had over the step to the house. And this is why it's not in the workshop. It's too difficult to get it into the workshop on wheels, so I just managed to get it sort of into the conservatory somewhere sort of indoors with some light that I can actually start pulling it apart and playing with it. As I said, it's made out, the construction is made out of this sort of aluminium machine building alloy extrusion stuff. So it is mounted. This isn't just plonked on the thing. This is actually sort of bolted onto this top. This top's actually made of corian, which is used for like kitchen worktops and so on. And the UPS is actually mounted on these sort of huge chunky aluminium brackets. I don't know if these were custom made for this or whether these are for this UPS, but they seem to be. The UPS is very heavy, but these brackets seem a little bit insane. And when I got it, there were side panels on it which are sort of still sitting outside. There was a keyboard drawer here, and there's also a second set of slides. Now there is a PC in here, but that was missing when I got it, which is a shame. But I think these slides here were probably for a rack mount, one new PC. And just down here, this is the power supply. Inside here, there's a cool CCD camera, so this is just the power supply for that. Around the back there's a sort of box full of electronics here with just a load of cables coming out the top unit down into it. There's a fibre, I'm pretty sure this is almost certainly the data output from the camera on a fibre, so this would have gone into the PC. The side here, I don't quite know. There's like a sort of circuit breaker, that's sort of the user on off switch there that went down into this. There's a little filter module here, and there's a warning about high leakage current. That's probably because of this big mains filter. There'll be probably quite a lot of capacitance to ground, which may well trip a normal RCD or a GFCI, depending on what country you're in. So on the UPS connector, there's this little board up here. I can't quite figure out what that is. It's all it seems to have is sort of 12 watt regulator, a few components, and a read relay. But it was tied into this switch, so I suspect that is just some way for the on-off switch state to be sort of conveyed to the PC, maybe via perhaps one of the serial handshaking lines. Because obviously, if the thing's on a UPS, the PC isn't going to know whether you've got a power failure or whether the user's explicitly turned it off. So I'm guessing that's probably just a way of telling the PC that the user has actually hit the switch. Surprisingly, these connectors, although there are a few different sizes of D connectors, there are a few that are the same, and then they're not marked. Obviously, I took the precaution of just scribbling some numbers on there before I unplugged anything. But for a piece of kit this expensive, I'm rather surprised that there's no labelling on here. There's no labelling on the cables or the connectors. I'm not sure whether this really almost looks like an afterthought. There's sort of these two tubes coming out here that goes down to this. And this fixing, my guess is that's probably to perhaps a vacuum pump or something, or to drain, or a waste for when you obviously before you run this you do like a washout cycle. So perhaps that's the waste for that. But this sort of looks like these have just been stuffed out of existing cooling vents. You'd have thought if this was designed in from day one, they'd actually have like a little panel or something with that on. It just looks a little bit of a bit sort of, I suppose, the fluidics equivalent of a bodge wire. I really expect this to do much when powered up, purely because obviously it's all controlled by the PC. But if I turn the UPS on, we get a lot of fan noise. There's fans in the UPS, fans in that camera power supply, and there's quite a few fans in the main unit. And we just get this orange light, and after a while that just starts flashing. Haven't even heard any sort of clicks or whirring from the unit. Oh, there you go, it's flashing, and that's really all it does, so not very interesting. Now on the front of this unit there's a couple of bits that you can get to. This is the main sort of cover here. Now I think one of these two gas springs has gone leaky because it doesn't actually hold the lid up, it just drops down. I'd certainly expect that to stay up on say £500,000 for a piece of kit. I'd really expect not to have to hold the lid up when I'm doing stuff with it. One thing I noticed on this is the actual surface finish is really nice. It's almost like Apple level, super smooth finish to it. Very sort of shiny. It's quite obviously there's been a lab environment, so any dents that have appeared I'm sure have happened sort of on its way through the recycling thing and on. I'd be interested to know what process they use to manufacture this, because for something this size it seems to me a bit unlikely that they'd actually do proper full-on injection mold tools. This is probably only made in sort of quantities of hundreds, I would have thought, or maybe low thousands at most. So to do like full-on injection mold tooling for something of this size I would have thought would be crazily expensive. So I'd be quite interested to know what they might have used. So for example on these logos, these feel, you can actually feel, you can feel the thickness of that, but it's like, again, super high quality, very hard and very sort of tough finish. I was wondering if some of it might actually be perhaps some sort of vacuum forming process, because you've got a fairly thin, fairly consistent wall thickness on there. But then again, you've got these sort of three-sided sort of folds. I don't really know how practical that is to do with some sort of vacuum forming thing, or whether there's some process where they can sort of almost glue sheets together and then finish it off afterwards. But certainly this outside finish is very smooth. So if anyone knows how they make this sort of stuff, please leave it in the comments. And you're looking at some of these internal details. For example, this insert, this has got very square edges, so I'd imagine this was a piece that's been attached afterwards, because if there's an injection mould, I don't think they'd want to get the edges that tight. Also, there doesn't seem to be any draft angle on this, so I'm pretty sure this has been attached afterwards. So it looks like, this main body looks like it has been sort of formed out of sheet, and there's some posts in here. Again, these have probably just been added or glued afterwards. I just noticed in here there's a date of August 2011 for this plastic piece, so this is manufactured sort of probably around sort of 5 years ago. No, I can't see any of the usual stamps you see for the recycling marks. Also, you can actually see some sort of signs of maybe some solvent welding or some thermal welding here around this block. There's some. Well, I've just taken this lid off because it wouldn't stay up by itself. So in here we've got the section where all the reagents are put in. This sort of lifts up like this. So we've got these little tubes that dip into these test tubes here. This whole section comes out. This feels like it's all made of Teflon, so there's no markings on here. looking through the documentation, it mentions sort of some tubes are used just for washing it out, and it's not totally clear. Certainly the smaller unit, there's actually like a pack of reagents that comes with, it's like a set of tubes in the right position. You put the whole thing in like a cartridge. It may be the case for this one that maybe you get like a cartridge that drops in here that's got all the reagents in all the correct holes. So it's snapped off the top, and nice sort of aluminium, anodized aluminium pieces, and so there's massive great chunks of Teflon. And this also, as well as popping up like this, it sort of swivels round. These tubes that dip into the test tubes, these you replace these again. Part of the kit for each run comes with a set of these tubes, so obviously you replace all these so that they're clean and sterile inside. In the documentation is after you finish your run, leave the stuff in place, because you then use these for washing it out before doing the next one. So you use the leftover pieces from the previous run to just flush through the machine, then you replace all these. Looks like these have got some filters, either a filter or sort of flow restrictor or something on top of these ones on the right hand side. And this top cover is actually held on by thumb screws, so it looks like it's designed to be fairly easily removable for cleaning or whatever, but there doesn't really seem to be all that much in here that's you'd actually want to get at. It's just the end of the ends of all these tubes. And again, we've got this looks like it probably is a vacuum formed thing with post glued into it. There's none of the normally on plastics you get like a mark that says what type of plastic it is for recycling, but I haven't seen any of those on this yet. Under that second cover, again, I don't quite know why they've got two covers there, but so the second cover again, you've just got the tops of the tubing, as well as these cables are just what these levers operate. So they just go down on cables down to wherever the other end is for the latching mechanism. Alright, looks like those tubes that stick out the back, they look like they go into here. One of them goes sort of down into the machine, and one seems to, that also comes down from two tubes into that machine, so I still don't really know. That's interesting. Maybe this is why you need to get in here, because there are different, perhaps depending on what you're doing, maybe you have to reconfigure these tubes differently. So there's these two loose ones here that don't seem to go anywhere. So these are marked R01, R02, W02, W01. So yeah, maybe the reason that this is relatively accessible is that you actually need to reconfigure these for certain types of operation. And these tubes go into this rubbery tube down to the main unit. One thing I noticed on this tube section, this tube at the back sits in here, and there's some foam rubber here, so I'm guessing this is going to be either a heater or cooler to control the temperature of this reagent. Again, looking through the bits of information I found, the reagents need to be stored at a specific temperature. I think they're actually frozen, and then you actually defrost it and then have to keep them in the fridge at a certain temperature before doing the run. I'll put a link down below. I did find like a procedure manual. This isn't just a case of throw the stuff in and press the button. There's a lot of preparation work that you need to do, as well as the actual cost of the materials. It looks like it's quite labour intensive, just the process of preparing the samples, and you need like centrifuges and various other bits and pieces just to actually be able to use this thing. So it's obviously a fairly major investment if you want to get into the DNA game. And in here looks like we've got a sort of steel spring that acts as a counterbalance. And this piece at the back, this is a chiller. You can see there's some Peltier coolers there, heating and a fan on the back. Interesting, there's like an over temperature switch there, but there doesn't seem to be any sensing of the actual temperature, so obviously this isn't particularly critical. It's just sort of wanting to keep it a bit cool, but it clearly isn't super fussy about the actual temperature. There's no, say the only wires I can see, there's the two wires from the Peltier elements, and I can't actually, so there's a little PCB that breaks out the wiring from this D connector, but as far as I can see there's actually no active temperature sensing on that, which is a little bit surprising. The next piece to come off is this, and this is according to the info I found, this is the pumps and debubblers. And this whole section slides out. And so it looks like we've got 4 peristaltic pumps here. This looks like it's designed to sort of come out reasonably easily for maintenance. So this is where all those tubes come in from the reagent test tubes, and this looks like they're going into some big manifold, and I'm guessing these are some valves. And on top of here we've got this colossal big chunk of metal whose sole purpose, as far as I can see, is just to sort of hold this lid on. There's a couple of magnets in here, so this just sort of sits on there and holds there, but it seems to be a slightly ridiculous sized chunk of metal just to do that. Now, this whole manifold assembly, there is actually a pin here that releases the end, which in principle allows it to swing up, pivot there, except there's a whole load. It looks like you've got to take quite a few of the tubes off to do it, because it's being held back by some of the stuff in here. And it's also being held back by all these connectors, and this bit's in the way, so it looks like when the whole thing's mounted in this box, it doesn't actually swing up. So here we've got the back of the stepper, so there's 4 stepper motors driving these peristaltic pumps. There's something in a can here, 4 sets of wires going into it, and just 1 tube going that end and 2 coming up this end. So what's in here? A couple of slightly unusual things I've noticed. Firstly, for an American piece of kit, all the fasteners seem to be metric sizes, which is quite unusual. They tend to be UNC, but also they seem to have broken the sort of unwritten rule that expensive lab equipment is only allowed to use Allen screws. There's actually quite a lot of sort of standard cross-point screws in here. So despite the, for example, if we look at this huge chunk of metal that seems to just be about sliding this in and out, deviated from the those rules for some reason. But so I'm a little bit surprised to see pretty much everything metric in a US made piece of kit. Perhaps they're seeing the light at long last. Okay, I'll take a detailed look at this fluidics unit on the bench once I've done the rest of the major demolition. So the other part, which is sort of to some extent the business end, is this. Pull this down. Now at the back, this is the imaging plate of a cooled CCD camera. This is like I think this looks like a fibre optic coupler, and essentially it's quite a large area, so it'd be interesting to see if there's actually optics to reduce that, or whether it's actually like a very large area CCD, which, and if it is a large area CCD, that might go to some way explaining the cost, but we'll get into that later. And down here, well, this is the plate where sort of the magic happens. Read a few little details about this. So this sort of part, this has got the tubes running through it. So there's basically 2 tracks, sort of top to bottom here. So that the part of the process is combining the DNA with tiny little nanoparticle sized plastic beads. They then go through this, which I think they call a pico-titer, or pico-titration plate. So this is feels like glass, and the sort of looks like there's various sort of metallization or sort of deposited layers on the back of this. One thing I noticed when I was handling this is that my sort of fingers started feeling very slippery, and I don't know if that's because of the micro beads here, or whether there's simply some silicone. There's a gasket on here, but I think we'll stick this under a microscope to see if we can see anything interesting going on there. Now, I don't know whether this is like a sort of permanent part or consumable, or whether this is something that comes with your kit of 6,000 Ks worth of consumables, and you use it every time. I don't really know. I've not looked in sufficient detail at the documentation I found to tell, but this is obviously designed to come out. And basically what happens is that the camera images this, and the different bases in the DNA sort of react differently and produce light. It picks up this sort of image, and then from that it works out all the DNA stuff. So I'm not sure whether sort of looks like comes in here. I don't know quite what the sort of whole four parallel tracks are, but so I'll see if I can dig out a bit more information on this and link it in. And but this is sort of clearly where a lot of the magic is going on. Nice sort of gear mechanism here to actually push this down and then sort of compress that against the camera. A very sort of satisfying clunk when that goes in. And there's a few odd bits behind that plate. Got a couple more valves and a couple of little manifolds here. So that's her board here. There's this connects a mock thermistor, so there's probably a some heating or possibly even a Peltier. I don't think there's enough. That one's marked thermostat, maybe that's just a cutout. Yeah, just looking at the starting basically from the wires that are coming into here, we've got this one that splits out into these two, so these are the valves. Then the only other wire comes onto this board, so we've got this one's marked thermostat, that one marked thermistor, and then there's this cable here. Just about to see that's going to something underneath the plate, sort of here and here, and it looks like it's capped on, so I'm sure that's just going to be like a flat, a sort of thin flat heating element. A bunch of LEDs in there that light up this big chunk of acrylic for the big status light in the front. So in the back we've got this huge great fan, a big lump of tubing, and what presumably is the camera. Somewhat massive heatsink. One other thing which took me a while to figure out how to open this front thing, it's actually got like an interlock thing. There's just sort of the end of a Belden cable here that when it's pulled forward it sort of locks it, but I'm not totally sure exactly what that's meant to interlock with, whether this is just a safety feature so that you can only pull that lever if you know, under some condition, but I'm not totally sure what it is that actually engages with that. Alright, actually I think what's going on here, this is the equivalent of the old paper clip to get floppies and CDs out. It looks like there's a couple of wires in here, so I'm guessing these here are probably rotary solenoids, so that once you close this thing up and start the run, these probably lock to prevent anybody accidentally opening it and ruining the ruining that run. And then this is like the emergency, so if the thing dies and you need to get it open when there's no power, you probably pull this, which then sort of pulls this open and allows you to release the egg. So that's the lock position. See, that actually prevents that opening. So it looks like that's the sort of openable position. So once it starts, this solenoid pulls that in to lock it, so you can't open it. But then when you pull that cable, that just gives you a forcible override. So with that front thing off, we've got a rather impressive and serious looking piece of kit in here. So we've got some rubber anti-vibration mounts on it and a ridiculous number of screws holding it together. So this is the camera unit. So this is it's a Spectral Instruments 800 series. I've emailed them to see if I get any information on this, so I'm not going to sort of tear into this until I know a little bit more about it. But so we've got, what's a bit puzzling, I mean, it's got this heatsink, but this looks like it's made out of stainless steel. I mean, why would you make a heatsink like that out of stainless rather than aluminium, unless it's to do with thermal expansion? So obviously we're going to have a Peltier cooler in here, so this is dealing with the waste heat from that cooler. And so we had this massive great sort of tube and a great big 18-watt fan in the back to pull air out. Now I'm not sure to what extent that is because it uses a ton of power, or just they want to keep the temperature as low as possible. So until we get some specs for this, I mean, the actual Peltier itself is going to be on the back of the CCD, so it's not going to be huge. Now on the back of here we've got the connection for that power supply box, a shutter and auxiliary connection, and the, let's have a look, Yeah, the 4-pin aux, that was connected back to the control box, so maybe that can control, control exposure or synchronization or something. There's the fiber port here. Looking at the website, it looks like this might be fiber Ethernet. If it is, then it means hopefully there isn't a special, exotic card that you need to pull the data off at the other end. So that might be potentially have potential to get it running. And also there's I think it says vacuum valve, and this is a vacuum port. So obviously, if you according to the info on their website, versions of this can run down to minus 60 degrees C. So obviously, if you're running that cold, you want the thing in a vacuum, just for thermal insulation, so you don't have to deal with sort of heat loss and so on. But I'd imagine there's possibly a few astronomy people that are sort of wetting themselves at the sight of this thing. So it would be quite nice. So I will try and get some info on this. If anyone has any information, then please get in touch. That might have to wait for another video, depending on how quickly that information comes through. This back cover does actually come off quite easily. There's a little fan on the side. Can't see a great deal in here. This thing can be built with different CCD options, so again, without knowing the exact version, don't know exactly what's in here, but we've got this side we can see a Xilinx Spartan FPGA, some linear voltage regulators. What I'm guessing there, that's probably 4 A to D converters, and some sort of front end analog stuff. Then on this side we've got some other various odds and ends. This may be the CCD driver. I can see another Xilinx Spartan in there and some other stuff, so probably processor in there, maybe some of the CCD drive stuff on that side. And it looks like the Ethernet that fibre optic thing's connected there as well. And on this side we've just got a crap load of analog, so actually I think that may well be generating all the voltages and drive for the CCD. And it looks like we've got a connector at the back which probably goes on to my guess is the sort of the CCD. There'll be like the Peltier and then the CCD on top of it, and then there'll be sort of some pins that go down onto that connector. That's probably a hermetically sealed sort of connector to get through the vacuum. And on here we can see the vacuum ports, valve. Nothing else obviously visible. Now, I probably could take this heatsink out, but I'm just not going to. There's so many screws. I'm just going to leave this until I've got some more information. If I fail to find anything, then I will start tearing into it a bit more. I do have a vacuum pump, so I could pump it down again if I wanted to get inside the vacuum thing to have a look at it, and then pump it back down. But obviously it's going to be down to what I can do in terms of getting. It would be really nice to actually get this running, and so it probably would be quite interesting to people that are into astronomy and stuff like that. These cameras are used. There's a few application areas. One is this type of thing, sort of the analysis. The other is X-ray type things where you use it to detect very faint fluorescence of X-ray phosphors, and also say astronomy is another big application. So yeah, but the whole point of having a cooled CCD is to reduce noise, so you can get improved sensitivity. Incidentally, some of the information I found was that in a complete run this thing produces about 35 gigabytes of raw data, which certainly 10 years ago would have been a not insignificant thing to deal with. Again, I'm not sure whether the size of the CCD is going to be sort of comparable to this faceplate, because they also do a version which has got like a tapered fibre, so that you've got an imaging size thing this big, but that then sort of tapers down onto a smaller CCD. Right, so that's pretty much it for stripping this thing. It's a massive great casting. This was to hold the monitor arm. The whole thing is built on a plate. I think it's about 12mm thick aluminium plate for rigidity. What was a little bit surprising is this plate is screwed down to the Corian base. Yeah, the locations of the screws mean that must have been screwed down fairly early on in the manufacturing process, purely from the point of view of how, where you can access those screws from. I would have thought it would make more sense to build this whole complete unit and then screw it down to the base, but it looks like that wasn't the case. just purely because there are some screws that you've got to take quite a lot of other stuff out just to get to the top of those screws. Whereas I thought it'd be a lot easier if they'd have maybe just put some tapped holes in the base and then just screwed it in from underneath. It means they've got this sort of great big lump of corian attached to the thing all the time, in the factory and everything, which seems a slightly strange thing. But I mean, there's a few odd things about the way this is assembled. There's a really annoying mix of screw types. There's hex, there's posies, there's nuts, and Torx as well, in an almost sort of random selection, which is quite unusual. So normally on something like this, it's generally all hex and nothing else. But there's a real strange mix on this thing. It's almost as if different bits were maybe designed by different people with different preferences in their own preferred fastener types. But so I'll just finish breaking this down into small bits just to get it out of the way, and then we can start taking a closer look at some of the electronics. Incidentally, that up and down movement on the bit that was in here with all the tubes going down, I mean, that's actually like this super precision Japanese sort of ball race bearing things. I mean, this sort of thing you'd find in ultra precision machines, but all this was doing was taking all those tubes down to dunk into the solution, so it doesn't really need any serious amount of precision. So I'm a bit of quite serious overkill on the mechanical build there. Instead, in terms of how this thing is made, I've just noticed on here there's actually evidence of a join here, so it looks like this maybe is made up out of separate pieces that are probably sort of glued together and then finished. But so there must be some sort of process they use for finishing the outside, whether it's maybe laid up into a mould, a bit like the way that fiberglass is done, with like a coating on the mould to give it the final finish. I don't really know, but so it's a very nice sort of quality finish. Just take a very quick look inside this UPS. This is a 2200 VA UPS. So there's two sort of massive great transformers. It'll go down to this board. Interesting, there's a whole bunch of relays on here. So I'm wondering if this perhaps uses tap changing to adjust the voltage. Main board all through hole. Interesting, the processor is an 87C52. Pretty old design. Various bits of analog stuff there. Transformer that might be providing a DC supply for the electronics on here. Some more relays back there. There's switching the mains. Some mains filter chokes. There's a sort of box here. I think this is for like an optional module, probably for like a network interface or something. The mains output sockets there, and some circuit breakers underneath. Battery fuse, 100 amp fuse for the batteries. There's 8 gel cell batteries that go in here. I just took them out to reduce the weight of this thing. Obviously these are rather heavy. They plug into these chunky connectors. And there's a fan in there blowing air across the heatsink. So we've got 5 devices on each of these 4 heatsinks. So this is probably an H-bridge. In fact, you can actually see that the transformers are actually connected directly onto these heat sinks to connect to the tabs of the transistors. Screw down the heat sink. Some funky looking tall capacitors there. 75 volts, 1500 off. That's probably just across the battery supply, but they're ridiculously tall. There are some unpopulated parts. I think this model comes in 2200 and also 3000 VA versions. So obviously the high power ones, they just obviously populate those extra transistor positions, that extra cap, and there's say some couple of other relays, might be some other build options. And so this is a 120 volt output, but it will work on 120 or 240 in. So that would be quite handy if you actually wanted to run some 120 volt stuff in a 240 volt country. But obviously it gives 120 out whether it's on main supply or running off the battery. But say none of the gear in this rack actually needed 120 at all. It was all universal voltage. So, but obviously if this thing was assembled in the US, then this is probably like a standard US version UPS that just happens to have universal input. So it makes sense that it uses 120 out. Well, I've just hooked all the electronics up on the bench to see if anything interesting happens, and there's not really much going on. I found a serial header on the board. And once it started, you just sort of get various bits of debug information, but there's nothing really of too much interest. The fan starts up on that cooler unit in the reagent section, and the pump motors sort of vibrate, but they're not rotating. It's almost as if the stepper phases are wrong. They're just sort of sitting there buzzing rather than actually turning, which seems a little bit odd. One thing I did find via U-boot is its configured IP address. So using printenv env, it shows a few environment variables, including its IP address 192.168.0.111. And the only service I could find on that, there's this HTTP page that just links to a few sort of log files, but there's actually nothing. You know, they all appear to be blank as far as I can see. You see, there's these link to what look like internal server names. They've obviously got a server called Pink Floyd. There's not really found anything else of any interest on there, so best we could hope for is sort of flipping a few valves and so on, but doesn't really seem to be very exciting, so never mind. Well, let's take a look at this electronics box. And the first thing that struck me about this, I've already taken this apart just to show you how it went together, is just how cram-packed it is. It's got this power supply in here, main board under here and a fan, but it's just unnecessarily squashed into a tiny space. There's also another huge great mains filter on there as well. And there's filters everywhere. There's like lumps of ferrite on just every piece of cable. A lot of the internal cables had like 2 ferrites at one end and 1 at the other, so it's just totally sort of filter city. But say this has been sort of crammed into quite a small space. It's got a ridiculously powerful fan in here, and that's not just a noise. Yeah, that's not just sort of a noisy fan. It's a fan that's really going some just to keep this cool, but it just seemed a little bit unnecessary to create. This massive great cart this thing's mounted on. It really didn't seem to be any point in making this this small. But it's 24 volt, 21 amp power supply. Pretty much everything runs on 24 volts in this thing. So this is the control board. Nothing really too surprising on here. We've got there's an Atmel ARM AT91 RM 9200 processor, a couple of SRAM, some flash, connector there which could be JTAG for the ARM, a few LEDs, reset button, there's an SD card slot presumably for loading firmware, Ethernet PHY, it's got USB host and device, but I don't think those are actually used in the system. RS-232 transceiver, so that's a serial port header next to it. Interesting, it's got a real-time clock crystal, but there's no battery in this thing anywhere, so it may well be this is a generic processor board they use on a number of different products, or they just stuck that on there in case they decide they were going to need it and never actually used it. But there's no sign of any, there's no footprint or anything for a memory backup battery. A couple of connectors there, those are probably just spare expansion connectors for other product variants or something. There's a DC-DC converter, 24 volt in, 3.3 volt out for this board, and a filter next to it. That's pretty much it. Then we've got this bottom board which is all the interfaces for the machine, various drivers and so on. So we've got some sort of stepper drivers down here. There's a Xilinx Spartan 2 FPGA here, and that'll be its configuration PROM. There's a connector here that's actually wired out to a header on the back panel, so that's almost certainly going to be JTAG for FPGA debug. DC-DC converter there. Nothing on the bottom side. A couple of fuses. One thing, there's a 10 amp solid state relay on there. I wonder if that might be controlling the power to the Peltier cooler on that unit by the reagent tube. I can't think what else it would want to switch on and off. That would need sort of a significant amount of power. I can't imagine anything else. I can't think what else that's in that unit that would need, you know, that fairly significant amount of power. Yeah, I can't really be bothered to trace out to figure out where that goes, but yeah, so just a few various linear regulators. Again, lots of filtering on the IOs, filtering and back EMF protection on the stepper motor outputs, and really not much else of any interest on that. And this is sort of the pump and fluidic section. So these are peristaltic pumps. This rotates. There's some rollers there, and these sort of squeeze down on this silicone tube, so it sort of squishes the fluid through. It's very commonly used on medical and lab equipment because the roller is sort of rolling a precise amount round. They pump a very predictable amount of fluid through on each step of the motor. So they're quite commonly used where you need to sort of dispense an accurate amount of fluid, but also the only thing in contact with with what it's pumping is this tubing. So you can choose different types of tubing to be compatible with whatever material you're pumping, and also you can replace that quite easily if you need to. Now, it turns out from the manufacturer name Introtech, these are bubble detectors. So the idea is it uses ultrasonics to determine whether or not there's liquid in the tube that's passing through. Now, so you can see this is showing red when there's air in the gap, sort of with like a bubble in the tube, and if we put some fluid in the gap, it detects the presence. According to the website, these things are used quite often in things like medical equipment to make sure there's no air bubbles in various fluid lines. So it's obviously just the ultrasonic characteristics of an air gap are different to a sort of effectively a solid, because you've got these soft solid jaws sort of touching the tube. Obviously the conduction through that is different when there's air in that gap. I've got most of this rubber stuff off. There's some sort of secondary potting. There's this sort of white compound that's holding everything in place, and then the rubber encapsulates everything. And there's a few passes and an 8-pin, probably a microcontroller of some sort. I don't recognise that package. It's like a sort of SOT23 sort of size, but with 8 pins. And you see the transducers. I've broken that off a little bit there, but they're just rectangular ceramic pieces there. And just poking around on this, found a 3 megahertz burst. So it's just sending these bursts of ultrasonic and then picking it up on the other side. So the rest of this box, we've got this manifold with all these valves on it, which we'll take a look at in a minute, and a PCB, which is just obviously got the drivers for those valves, and nothing particularly interesting on this PCB. There's just individual transistors driving the valves and a LED by each one. It's a Xilinx 9572 CPLD controlling it all. There's an op-amp and a comparator there. I think that might be to do with that temperature sensor we saw on the camera door PCB. And there's actually 74 HCT 9115. Never knew that 74 went up that high. It's just a 9-channel Schmidt buffer. It looks like it's being fed from the cable that comes in from it. So that's perhaps a parallel interface or something to for the data to come in to control this thing. But the only other thing, there's a TPIC 0107, which is an H-bridge driver. That's used to drive these two solenoids which we saw on the cover latch mechanism. And in fact, I thought these were solenoids, but actually they're not. And they're actually sort of sprung to a sensor position, and depending which way you drive them, they either go in one direction or the other. Interesting on the sides, first time I've seen this warning. Internal high energy magnet. If the product is disassembled to expose the magnet, pacemaker wearers should be greater than 10 feet 3 meters from the exposed magnet. Now, if I had a pacemaker that was sensitive to anything short of an MRI machine at 3 meters, I'd be rather worried and want my money back. So this is the valve and manifold assembly. So this is basically a block of acrylic. It's got various holes drilled to allow fluid. So it looks like we've got sort of a bunch of connections here, and it's a bit hard to see because this side isn't particularly well polished, but it looks like there's sort of like a continuous chain. Each of these valves is like a changeover type thing. So there's either like a straight path all the way through, or it switches one of these into that path, presumably to suck up whichever reagent it wants to, and then there's probably an alternate one where it can suck up the sort of cleaning solution. Now this manifold looks like, just looking at the holes, this looks like it was probably sort of drilled from four sides. There is actually a process called diffusion bonding where they can actually make multi-layer to get internal cavities, where they take multiple sheets of acrylic and then basically apply temperature and pressure to effectively form them into what looks like a single piece, but it's actually got sort of internal cavities that you wouldn't be able to drill from outside. But so this looks like I can only see sort of right angled holes that start at one face. So this has probably just been drilled. And these are sort of valves from SMC. These are like a sort of like a rocker type valve, and according to the data sheet, they're designed to minimise any pumping effects. Obviously, when the valve flips, there's some change in volume, so you don't really want your valves to be adding sort of any pumping effect. And you can get these with different diaphragm materials, depending on what chemicals you want to pump. You can actually see there's the shaft there. You can see the rocker there. So this just sort of rocks between these two ports. Right, so this is the camera cover plate. Take a look at that under the microscope in a minute. So as you saw, there's not a great deal going on here. There's a couple of valves here. So we've got this centerpiece here, which has just got a quite a powerful spring in it. Push that in. So obviously that's pushing the this plate in towards the. Not sure if that's pushing it towards the camera or just maintaining. It might be just maintaining compression onto this. But obviously just to maintain this. So it looks like this. It's got a gasket on there, and this presses against this ball bearing there, which I think should push this whole plate in. So yeah. One slightly surprising thing is on the underside of this board there's a bunch of LEDs, which I can only assume are for some sort of calibration or something for the camera, because obviously they're facing in towards the plate. Through, yeah, they shine through these holes. Interesting, they appear to just shine onto this. I don't know if maybe those are a bunch of fairly dim red LEDs that are shining through there. They seem to be sort of hitting. And this is maybe a very thin material that lets a tiny amount of light through, perhaps. And so we've got these two valves. One of them is labelled debubbler. This is on this little manifold where we've actually got a little section with a cavity in here. Looks like they've yeah, I think this is just a section that's been machined out and then a triangular piece glued in. It's got this little Y-shaped thing, so that's going to the plate, and then there's two paths going to two different tubes there. And the other thing, one of these tubes, these go behind these plates, and there's some heating compounds. So this is clearly to make sure that this, whatever's flowing through here, reaches the same temperature as the plate. Possibly, sort of, if it's waiting until this valve opens to let it through, so it's preheating it to whatever temperature the plate's at. And this will be the heater for the plate. Yep, so there's just a couple of thin film heaters there, and there's a thermistor under there to measure the temperature. So I tried looking at this thing under the microscope. I can't really see anything other than the sort of hexagonal array. Found this little bit of video on YouTube that sort of gives a rough idea of what's going on. You've got sort of DNA strands attached to these beads. You then get sort of packed into these little cells, little hexagonal cells, and then the various chemicals react, producing light according to the various types of DNA. I assume it sort of puts one thing through at a time to identify each of the 4 different bases. I think these bits of paper just represent the different bits of information that then get compiled into the info afterwards. So onto this camera. This is the camera power supply. As you can see, it does quite a few different rails. You've got plus 24, plus 30, plus minus 13 and plus 5 volts, as well as the supply for the cooler. Nothing too surprising in here. There's 2 Meanwell 100 watt 15 volt power supplies, and then over on this board there's a ton of regulators. There's some LT1683 ultra low noise switch mode regulators on the underside with these sort of output transistors and inductors. Massive great inductor here, and then it looks like they've got sort of linear post regulators here and sort of great big caps, because obviously if you're going to the trouble of calling your CCD to reduce noise, the last thing you want is noise on your power supply. So yeah, this is obviously designed to be a super clean low noise power supply. There's got output connectors there for this multi-way plug, and obviously there's provision for different connectors, obviously for different models. There's a few unpopulated sections for another supply rail, but nothing too surprising here. It's got this funky heat shrink sort of ribbed for your pleasure, and we've got a test date of January 2012 on the box and also on the cable, so definitive idea of when this thing was made. Not much to go on at the moment on the camera. There's this aux connector on this LEMO plug goes onto the electronics box, but there's only 2 pins connected, little cap across there, and I did actually trace this all the way out onto this board, and it just goes to this transistor that seems to switch it down to ground, so that's probably going to be just some sort of enable type thing. I've had this running for a while, and this heatsink doesn't get warm at all, so I'm guessing the cooler isn't turning on. We've also got the red letter here that says COM fault is lighting up because it's not seeing anything on the other end of the fibre, so I suspect it needs to be actually actively told from the computers to switch on. So I'm going to leave this camera to another video, say pending, if anyone knows any information, say it's a Spectral Instruments Model 800, part number 6116. There's probably quite a lot of variations and customization, so this is almost certainly customized for this application. It would be quite nice to get this running, particularly if it's going to be useful for, say, astronomy is the obvious thing for a cooled camera. With I think that there are a few different CCD sensors they could fit to this, so again, I don't quite know what will be fitted for this, but it probably is quite a big sensor and quite a high resolution sensor. It could be something like a 2K by 2K sensor. Now, what would be particularly useful to get this, what could be interesting, say if this does prove to be useful, obviously because this gear is pretty much obsolete now, there may well be quite a few of these coming onto the market. I've already seen a few. I've just had a quick search through eBay in various countries, and there have been a few going sort of very cheap at sort of scrap type prices. So it may well be that there could actually end up being quite a few of these floating around. So if we can actually get them working, it could be quite interesting. So if anyone's got any information, for example, how standard is this a standard connector that's used for Ethernet, or is it something a bit more special? There is a fairly standard high-speed camera interface called Camera Link. I mean, is this a standard fibre optic camera link interface, perhaps? I've not found any documentation yet on this apart from some sales material. So I have emailed the company, and I'll sort of I'll put this video out now in case anyone just happens to have any info, but if I don't get any joy, I'll maybe give them a call and try and trace that up. And failing that, it might be worth sort of spending a bit of time trying to reverse engineer it. I would expect this to accept sort of some commands to tell it. There's quite a lot of parameters. Looking at the documentation I found for some of the earlier camera models, there's quite a lot of settings, things like exposure times and CCD voltages, trigger modes, binning, gain settings, all that sort of stuff. So there's quite a lot of setup. So my guess is it's either Ethernet. Now, it shouldn't be hard to figure that out by looking at what's on there. I only had a very quick glance over that board, but I didn't immediately spot a processor. So if there's only the FPGA there, okay, it could have a soft core in there with doing a TCP/IP stack or something, but it could well be that it's actually a relatively low-level interface that just sort of throws data out. So it might be interesting to try and reverse engineer that if we can't find any concrete information. But say the annoying thing is not having the PC that went with this closed off a lot of potential avenues, because obviously a fully working system, we could actually probably get some data and, if necessary, reverse engineer it. But even just to know, for example, what does this plug into? Is it a bog standard card, or is it something special? Is it a special? And clearly the data is being digitized in here, so there will be digital data of some flavour coming down this fibre. The question is it something standard? Is it something sort of standard but a bit specialist like camera link, or is it something totally custom to this camera? I'd had a sort of quick look through the company's website. I didn't notice any obvious sort of listings for things like special PCI cards. There were some for some of the earlier cameras mentioned PCI cards, but for this model I couldn't really find any information really about the interface, other than they do a gigabit Ethernet version as well as fibre. So with a bit of luck it's fibre Ethernet, and it's relatively easy to talk to. But so I think if anybody knows anything or knows someone that might be able to get some information, then please get in touch. So it's Spectral Instruments 800 series, which apparently is still a current model, part number 6116. Okay, so I think I'll leave it there. I think it's getting towards an hour long video, so you might be able to get something interesting happening with this camera as well. And if you see one of these things going cheap, you now know what's inside it, and it might be worth grabbing hold of, especially if it's got its PC attached. I did see one picture. I can't find it. Can't find it again, but I did see a picture showing it was like an IBM rack server running on this thing. But again, over a lifespan of 10 years, that might have changed over the years. Another bit of interesting kit, which is I think it's actually probably by quite a long way the most recent bit of super expensive kit that I've managed to get my hands on cheap, because of the fact it's been superseded relatively quickly in a very fast moving market. It's sort of been superseded and made sort of obsolete at a sort of relatively young age. So as far as I can tell, it was only actually discontinued this year.